This week's lab is on quantum systems, specifically the hydrogen atom. The hydrogen atom's just got one proton and one electron, the electron orbiting the proton in orbitals with different energies, each labeled by the integer n. Say you have an electron in the state with n equals 3, and it decays down to the n equals 2 state. When this happens, a photon will be emitted. The energy of the photon will be equal to the energy lost by the atom. So say you have a gas of hydrogen and you run a current through it to excite the hydrogen's electrons to states with large values of n. As the electrons transition to lower n levels, different colors of photons will be emitted, each corresponding to one of the different transitions to a lower n level. We'll measure these wavelengths by using a diffraction grating to separate out the colors and measuring the diffraction angles for each color. We'll then relate these wavelengths to specific transitions using the Rydberg equation. Let's take a look at the spectrometer. On the input side is a collimating tube, which has an adjustable aperture so you can control the amount of light that gets through. The light that does get through the tube is collimated before it hits the diffraction grating. The grating is mounted perpendicular to the incoming light. Light diffracts from the grating and can be viewed again by a telescope. The angle between the telescope and the collimating tube is indicated on the platform of the spectrometer.
So to use this, you push the spectrometer directly up to the source. So all the light from the hydrogen source gets through the input of the spectrometer. And now if you look through the grating, you can see that there's the source. But we don't want to look directly at it. What we want to do is look through this telescope at it so that we can see the diffraction angles. So if I move this here and we try and look through the source, or look through the telescope.
You'll adjust the telescope angle so that the crosshairs are in the center of the band, and then measure the angle. As you increase the angle of the telescope, you'll see colored bands of diffracted light corresponding to the different hydrogen transitions.